Hello, my name is Mark, and I work as a core developer on Ethereum at Nethermind. And today I'm going to be talking about Surge, which is Nethermind's based rollup template, and how it's accelerating Ethereum's rollup roadmap. And a big thanks to David for creating the original presentation this is based on, and also to Lynn for his feedback. So rollups are just fancy multisigs. They don't really inherit Ethereum security. Rollups are still slow. So I think there's really some legitimacy in these claims if we look at the state of Ethereum's rollups today. We don't really see these as criticisms, I guess, but more as like a challenge. So how can we actually create a rollup which is neutral, which is trustless, and extremely performant? And that's really what Surge is all about. But before I get into Surge, I'm just going to give a quick background on kind of how rollups work today, if you're not familiar. So essentially, the high-level idea is there's a limit to how much we can scale the throughput of the L1 while keeping it decentralized. So the idea of the whole rollup roadmap is that we're going to do a lot of this computation off-chain, and then we're going to post a compressed proof to the L1 along with the transaction data. And then that's going to be verified on the layer 1 and also the data made available. And the way that most rollups work today is with a centralized sequencer. So essentially, we just have one entity who's going to be responsible for collecting all of these users' transactions, putting them in order, and then ultimately posting a batch of transactions to the Ethereum L1. And this works, but it has several problems, right? So we have just one single point of failure. So if this centralized sequencer goes down, it becomes very difficult to actually get your transaction on chain. And this is also a censorship vector. So we just have one entity who's able to just omit your transactions or just prevent them getting on chain if they decide to, which concentrates power with this one entity and relies on the reputation of this organization, company, whoever's running the sequencer. I mean, one caveat to mention here is you can have forced inclusion mechanisms. So this is a way where instead of going through the centralized sequencer, you can just actually bypass that and post directly to the L1. But there's several kind of negative parts to this. So it's going to take longer to go on chain. You're going to pay more potentially and be exposed to toxic MEV. So really the solution to this is based rollups. So with based rollups is the idea is we're essentially just getting rid of the L1 proposer. Oh, sorry, not the L1 proposer. We're getting rid of the centralized sequencer, and we're going to replace it with the Ethereum L1 proposer that we already have. So instead of introducing new infrastructure like the centralized sequencer, we're just going to reuse the kind of existing MEV-boost pipeline that we already have on Ethereum. And to kind of walk through how this would work, like how your L2 transaction ends up on chain, you're going to send it to a separate mempool, so to the L2 mempool, where these transactions are going to be bundled by the L2 block builders. And these L2 block builders are the same entities as the L1 searchers. So then this essentially from here goes through the normal MEV-boost pipeline. So the L1 searchers send the bundles to the block builder, who sends it to the proposer, and then it ends up on chain. And there's several advantages to this. So we're going to inherit Ethereum censorship resistance and liveness guarantees, and hopefully their security, depending on a few other factors. We're not introducing any kind of additional infrastructure in this centralized sequencer, and this results in just generally simplifying everything and making it a lot more cost effective. And just aligning everything with the base layer, so we don't really introduce these outside incentives. And there's also kind of big improvements in terms of composability, which I'll speak about in a little bit. So with Surge, what we're really trying to build is a neutral rollup. And what do I mean by that? So I would define a neutral rollup as a rollup that is permissionless, trustless, censorship resistant, open source. It's able to be operated and forked by anyone, all while remaining performant and reliable. And these are really what we're going for with Surge. So Surge is a base rollup template. And by template, I kind of mean this isn't just kind of another rollup we're deploying, but it's something that can be built on top of. So it's kind of made to be redeployed, built on top of by other people. It's stage 2 at launch, which I'll speak about in a bit, but this means it has very strong liveness, censorship resistance, security guarantees. it's based, as we've just been talking about. It uses only native ETH, so there's no kind of external token which is introduced, and 100% of the base fee is burnt at the moment, although this is subject to change on mainnet deployment, and it has extremely high like gigagas level performance. So how do we actually go about building Surge? So Surge is based on the Tycho Alethea stack, which is the most mature battle-tested based rollup stack at the moment. But we've made several modifications. So we've replaced the finality gadget. So now we have a 2 of 3 multi-prover system, which I'll speak about in a bit. We've replaced the bond token. So instead of any Tycho tokens, as I mentioned, it's just pure ETH. Changed the fee split. So as I say, at the moment, 100% of the base fee is being burnt. We've replaced the execution client. So it's no longer using rollup get, but it's based on the Nethermind client. And we've also added a lot of extensive documentation. As I say, it's all about people being able to build on top of it. And stage 2 security, what does that mean? So if you're not familiar, we have this website, L2B, which is about classifying different L2s by their security and trustlessness guarantees. So with Surge, we have a 45-day exit window. So that means if there's some kind of upgrade and you don't like it, you want to exit your funds, you have plenty of time, 45 days to actually exit your funds. There are no emergency powers, very limited governance. So unlike some of the rollups that exist today, where they have some kind of emergency backdoor where they could kind of sneak through some last-minute upgrade, essentially, we don't have any of this here. So you don't actually have to trust us. You don't really have to trust anyone. It's all kind of smart contracts, and as I say, you can exit your funds with plenty of time. And yeah, so there's no tokens, external tokens introduced. And this just generally aligns the incentives a lot more with the base L1. It doesn't kind of introduce outside incentives or kind of like speculation, and just generally removes any kind of overhead of like governance, distributing this token, market making, all of this stuff. It just makes it a lot simpler. And we have gigagas level performance. So this means billions of gas throughput per second, which is possible thanks to the Nethermind client, which has been demonstrated to have this kind of gigagas per second throughput. And this is possible all thanks to a lot of crazy technical optimizations by my colleagues working on the Nethermind client with me. So we have this 2 of 3 multi-prover security model. So what this means is the kind of state transition, or the proofs of the state transition, are going to require 2 out of these 3 different proof systems to all agree. So we're going to prove in this TE-based system using SP1 and RISC-0, and we have like a modified RETH kind of state transition function running inside this. But what all this means is we kind of avoid having one single point of failure in the prover. So we're not depending on one prover that could have a bug and kind of derail everything. And this is really important, especially for stage 2, where it's kind of locked in and you can't change stuff. So you kind of want to have this higher level of fault tolerance where you trust that at least 2 of 3 of these systems are going to agree and give the correct answer. So what can you do with Surge today? You can check out the website, surge.wtf, to kind of learn more. You can spin up your own kind of part of the testnet if you want to try it out. You can check out our docs or contribute on the GitHub, or you can actually start playing around on the testnet today. You just need to get some hood ETH from the faucet and bridge it over to Surge. And we have kind of several improvements or power-ups in the pipeline. The most important of these is pre-confirmation. So this is massively improving the kind of user experience of base rollups by giving pre-confirmations, and we're aiming sort of on the latency of sort of less than 2 seconds. So you're not going to have to wait for the full 12-second slot to get a confirmation of your transaction. We're working on also improving the kind of security of the proving architecture, the block building, and also just improving this kind of composability, which is a big benefit of base rollups. So yeah, the plan for what we're doing next is continue innovating. As I say, this is not kind of built as a as a base rollup in itself is more about this template that people can take and build on top of. We're improving the prover finality gadget. We're going to release on mainnet. And yeah, we really just want the community to kind of take over this project from us. And one example of this is Ethereum R1. So this is a project which was announced not too long ago. And this is a neutral rollup, which is kind of built by the community. And it's planning to be built on top of the Surge stack. So this is funded 100% by donations. I think the plan at the moment is to raise 1,000 ETH. And this, as well as all of the fees raised, are all going to just go to funding the development of the chain itself. And then after 2030, it'll be burned. And yeah, it's just community governed. There's no kind of external token or governance. And this is really the ethos of Surge. I want to just speak briefly on some of kind of how this base pre-confirmation system is going to work. So as I said, we're aiming for pre-confirmations on the order of less than 2 seconds of latency. So the way this works is essentially a pre-confirmation is just a promise from a future proposer that they're going to include your transactions. So what we need for this is that proposers are all going to hold some kind of stake, and if they don't honor the pre-confirmation they gave, so your transaction was pre-confed, it doesn't end in the block, then you can expect that someone is going to be slashed. And there's a few different ways this can be implemented. So the proposer themselves can issue pre-confirmations if they're kind of a sophisticated actor, so they have a high kind of bandwidth, low latency connection, and can kind of rapidly give out these pre-confirmations. Or it could be delegated to a pre-confirmation gateway or delegated to the builder through MedBoost. And one requirement of this is EIP 7917, which I think is planning to be included in Fusaka, which allows you to kind of look ahead and see who a future proposer is, so you can see who's the next person I can get a pre-conf from. And also I want to speak a bit about synchronous composability. So this is really, I'd say, maybe the biggest benefit of base rollups. So we get this instant atomic composability between base rollups and with the L1. So by atomic, I mean you can have one transaction which is going to like access or do stuff across all the state. And yeah, it essentially allows for unified liquidity across all of these chains, so between the base rollups and the L1, and essentially making it all feel like one chain again. So kind of to give a brief kind of idea of how this would work. So to send a message from the L1 to the L2, you would submit a kind of message to a contract on the L1, and then the L2 builder or L1 searcher is going to actually inject this message into the L2 within the same slot. And then it's also possible to go the other way, so have a message pass from the L2 back to the L1. So this will be kind of trivial in future when we have real-time proving. So you can kind of immediately prove what is the current state of the L2. But it's actually possible today through solvers. So solvers can condition their solutions on so they're going to create a batch of transactions, and they condition that this batch is only going to be validly included if this L2 to L1 withdrawal is going to happen. And this is kind of like a nice workaround that we can use until we have real-time proving. And if you're interested in that, we have a couple of posts from some research at Nethermind, which can give you a bit more information about that. And yeah, actually, I have one more slide here, which is about kind of another project which we're working on at Nethermind, which is slightly separate, but I think still related. So this is called Way. So this is a project we have, which is all about kind of automating core protocol development, which is very much kind of in the spirit of accelerating the roadmap. So the idea here is to have kind of these autonomous agents which are helping to coordinate between different Ethereum development channels, like understand the EIP process, and just generally be able to connect everything. So I think this is going to have kind of a big impact on accelerating both the L1 as well as the rollup roadmap. So I just wanted to kind of give that a quick mention. But yeah, so you can check everything out here. And yeah, thank you very much for listening. Yeah, any questions? Okay, I guess not. Thank you.